All right, so this question is about the impulse. It's kind of related to the momentum we just talked about earlier. So we have this problem where a man jumps, and here we talk about an initial velocity, a final velocity, and then we talk about the time that takes to have this change. So that is important because it's technically related to the force that applies to that object to have this change in the momentum. Now, the first question, what is the change in the momentum? We know the momentum is by the formula will be of any object is the mass of the object times the velocity of the object. Now we also talked that if we have a change in momentum, there has to be happening a change in the velocity because there is no change in mass in here. The man does not change his weight. Yeah, sometimes we need to change the weight, but that does not apply to this problem. So the initial velocity is considered to be 6.5 meter per second. The final velocity will be zero. So if you subtract anything minus zero, it will stay the same. So obviously the change in the momentum, and I'm gonna say delta p, the change in momentum will be the mass of the man, which is 80 kilograms. Multiply with, again, the difference between 6.5 and 0 is 6.5 meter per second. Of course, you multiply and you find the final answer. Whatever that is. If we need to do it, we'll do it later. If he hits the ground flat-footed, with the knees locked at 0.1 second to stop, so that would be the time. What is the force of his feet? Now we're going to have to look at the formula for the impulse. So we have the force, which we do not know. We do have the time of stopping. So I'm going to say we continue underneath 0.1 seconds. And that would be equal to the mass of the man, 80, times the change in velocity, which we just discussed, is 6.5. And here's the time when we need to divide each by 0.1 seconds. And let's don't forget the units of measurements for the other one. Okay, there you go. And the final answer would come as, let's do a division, 80 times 6.5 and all divided by 0.1. Comes exactly 5,200. Now the units of measurement, you notice on the top, you have kilograms, then you have the in this case, the meters, and you divide by seconds and divide again by seconds, that would be seconds square. So that would be the force. Pretty tough force. Now, however, if you notice in C situation, the time changes in 0.6 is 6 times bigger. So yeah, you can imagine the force has to be 6 times, not bigger, but smaller. But let's do the calculation for that. So the same formula would apply for this situation, which it's a different force now. I'm going to say the first one to be, and by the way, I'm going to say this is first force, the second force. All right. And I don't really like to say either continue with equal to here because that's not an equation. The left is an equation, the right is a number. So I'm just going to say comma and F1 just to be, equal to the final answer. And the second one, 0.6 seconds, is equal to the same 80 kilograms times 6.5 meters per second. But this time I have to divide by 0.6 each side to solve the equation. Okay.